विद्यार्थी मित्रों, लेक्चर नंबर 1 डिफरेंशिएशन विकलन। सपोज हम शू लीए डेफिनेशन f is from closed interval ab to r is real valued function, and for t belongs to open interval ab minus x, f of t minus f of x over t minus x is defined, and if limit t tends to x, f of t minus f of x over t minus x exists, then it is called derivative of f of x with respect to x, and is denoted by d by dx of fx or f dash x, that is limit t tends to x, f of t minus f of x over t minus x is equal to s d by dx of fx, or in other notation is denoted by f dash x. This is the definition. Now place here. Here limit t tends to x. So t takes nearer and nearer value to x, but it cannot be x. This is the reason why we are taking this thing. This one, this function is defined in this interval, and we already started. See, not here closed interval, but it is open interval. See, then if this function is defined, and if this limit is called, then it's called a derivative of a function fx with respect to x, and is denoted by d by dx of fx or f dash x. So in this way, this is just a definition of a differentiation. Clear? Now let us see. विद्यार्थी मित्रों, विकलन છે તો પહેલા તો f from विवृत अंतराल ab to r वास्तविक विधेय છે. t belongs to विवृत अंतराल ab minus x માટે f of t minus f of x over t minus x व्याख्यायित होय तथा लिमिट t tends to x, f of t minus f of x upon t minus x નું अस्तित्व होय तो आ लक्ष्य विधेय fx નો x ને સાપેક્ષ વિકલિત કહે છે અને તેને સંકેતમાં d by dx of fx or f dash x વડે દર્શાવવામાં આવે છે. આ ગુજરાતી મીડિયમના વિદ્યાર્થીઓ માટે છે આ વ્યાખ્યા, બરાબર. પહેલા વ્યાખ્યા બંને માધ્યમમાં આપણે આપીશું, પછી કોમન એક્ઝામ્પલ સ્ટાર્ટ કરશું. ધેટ ઇઝ એટલે કે limit t tends to x, f of t minus f of x upon t minus x is equal to d by dx of fx, or other notation is f dash x. આ એનું નોટેશન છે મિત્રો, સંકેત છે, આ એની વ્યાખ્યા છે. Now let us see. d by dx of fx, or other notation is f dash x, is equal to limit t tends to x, f of t minus f of x over t minus x. Clear? This is the definition of a derivative. d by dx f of x એને શું કહેવાય? Derivative of f of x with respect to x. d by dx of fx ને fx નો x ને સાપેક્ષ વિકલિત કહે છે. To find the process of finding derivative of function f of x, or in general any function, is called differentiation. એટલે કે વિધેયના વિકલિત મેળવવાની ક્રિયાને વિકલન કહે છે. ઇઝ એ પ્રોસેસ. આ ચેપ્ટરનું નામ શું છે? ડિફરન્શિએશન, વિકલન. એ હકીકતમાં શું છે? ઇઝ નથિંગ બટ ઇઝ એ પ્રોસેસ finding derivative of a function fx is called a differentiation. In place of fx you can take any function. ગુજરાતી માધ્યમના બાળકો માટે વિધેયના વિકલિત મેળવવાની ક્રિયાને શું કહેવાય? વિકલન કહેવાય. ખ્યાલ આવે છે? હવે આપણે બે ફોર્મ જોઈશું વ્યાખ્યાના. એક તો આપણે જાણીએ છીએ શું? ફર્સ્ટ વન, fx f dash x or d by dx of fx is equal to limit t tends to x f of t minus fx over t minus x. બરાબર. હવે જુઓ, સપોઝ ધારો કે આ t minus x is equal to હું h લઉં, તો t is equal to શું મને મળે? x plus h. હવે now t tends to x હોય તો h tends to શું થાય? 0. અહીંયા t is equal to x લઉં તો x minus x એટલે શું મને મળે? 0. And therefore d by dx of fx or f dash x is equal to શું મને મળે? limit h tends to 0 f of x plus h minus fx upon h. આ એની બીજી વ્યાખ્યા, એનું વ્યાખ્યાનું બીજું સ્વરૂપ. આ એનું ફર્સ્ટ સ્વરૂપ, આ એનું સેકન્ડ સ્વરૂપ. આ જે વ્યાખ્યા જે છે, જો ટ્રિગ્નોમેટ્રિક ફંક્શન્સ હોય, એક્સપોનેન્શિયલ ફંક્શન્સ હોય, લોગરિથમિક ફંક્શન હોય, એટલે કે ત્રિકોણમિતિ વિધેય હોય, ઘાતાંકીય વિધેય હોય કે લઘુગુણકીય વિધેય હોય, ત્યારે આ વ્યાખ્યાનો યુઝ કરીએ આપણે ડેરિવેટિવ મેળવવા માટે તો આપણને ઈઝી પડે. અન્યથા otherwise first definition. આમ તો ગમે તે ડેફિનેશનની મદદથી તમે એક્ઝામ્પલ સોર્ટ આઉટ કરી શકો, સોલ્વ કરી શકો, કઈ વાંધો નહીં. પેલા જોઈએ, ચલો વન બાય વન. પેલા તો આપણે સ્ટાન્ડર્ડ ફોર્મ્સ જોવા પડશે, પ્રમાણિત સૂત્રો મેળવી લઈએ આપણે. ચલો વન બાય વન આપણે મેળવીએ ડિફરન્શિએશનના. ફર્સ્ટ વન જે તમે 11મા ધોરણમાં લખેલું છે, ડી બાય dx of x raised to n is equal to nx raised to n minus 1. બરાબર? તો જુઓ, f of x બરાબર x raised to n લઉં તો d by dx of fx is equal to શું? તો કે લિમિટ t tends to x f of t minus fx over t minus x થાય. આ વ્યાખ્યાની મદદથી આ therefore ની જગ્યાએ આપણે આ સાઇનનો ઉપયોગ કરી શકીએ અને એને બોલાય implies. આપણે લઈશું ચેપ્ટર ગાણિતિક તર્ક, લોજિક. This implies d by dx of fx શું છે ભાઈ? x raised to n. Limit t tends to x. F of x is equal to x raised to n. Then what is f of t? F of x is equal to x raised to n. Here x, so here x. Here t, so here t. T raised to n minus fx x raised to n over t minus x. We already seen in limit. Limit variable tends to constant. Variable raised to n minus constant raised to n over variable minus constant n times constant raised to n minus 1. So here what is variable? T is variable, x is constant. So n times constant raised to n minus 1. So what we have a standard form? D by dx of x raised to n is equal to nx raised to n minus 1. See, this is the standard form. But see, very important note. In general, please remember this standard form. D by dx of some function raised to n is equal to n times some function raised to n minus 1 into d by dx of some function. આ કેમ છે એ 12thમાં જોઈશું, પણ આ સ્ટાન્ડર્ડ ફોર્મ પ્લીઝ લર્ન. આની સાથે સાથે જ આપણે આ ફોર્મ તૈયાર કરતું રહેવાનું. આ વધારાનો ઇન્ટુ ડી બાય ડીએક્સ વાળો પાર્ટ કર્યો છે ને, એ આપણે 12thમાં જોઈશું, પણ આ સ્ટાન્ડર્ડ ફોર્મ લર્ન કરો એની સાથે આને લર્ન કરી લેવાનું. ખ્યાલ આવે છે? આપણે અત્યારે પણ જોઈશું, એન્ડમાં બધું જ જોઈ લેશું. 11thના ચેપ્ટરનો એન્ડ કરશું ત્યારે આપણે બધું જ જોઈશું. હવે x raised to n કરી લીધું. હવે ચલો આપણે બીજું ફોર્મ લઉં હું. d by dx of e raised to x is equal to e raised to x. અહીં જુઓ, મેં શું કીધું? ત્રિકોણમિતિ હોય, ઘાતાંકીય વિધેય હોય કે લઘુગુણકી હોય, trigonometric functions or exponential function or logarithmic function, then use this definition for conveniency. Clear? Now see here. Suppose f of x is equal to e raised to x. Now d by dx of fx is equal to limit h tends to 0 f of x plus h minus fx over h. Now see, fx is equal to e raised to x. So f of y is equal to e raised to y. So f of something is equal to e raised to something. In our case, what is something? So f of x plus h. 1 minute. F of something is equal to e raised to something. So if I put here f of x plus h, then what we get here? X plus h. So next step, limit h tends to 0, here e raised to x plus h minus e raised to x over h. Yes or no? So that is equal to limit h tends to 0. If base same, then indices are added. So in this way we can simplify it. આધાર સરખા તો ઘાતાંકનો સરવાળો થાય એ પ્રમાણે આપણે એને છૂટું પાડી શકીએ. Here h is variable. See here, h tends to 0. So in left hand side, see, x tends to a. So in this left hand side is a variable tends to. Limit always tends to. Here whatever may be that we have to consider constant. And here whatever may be that we have to consider as a variable. So in our case, what is variable? H is variable. So here we can take e raised to x common. Limit h tends to 0, e raised to h minus 1 over h. And we know that that standard form, that is equal to into 1, that is 1. Sorry, that is equal to e raised to x. Clear? Next one, third. D by dx of a raised to x is equal to a raised to x log a by z. 1 minute. Here also remember this form. D by dx of e raised to some function is equal to e raised to some function d by dx of some function. આવું અત્યારે શું કામ યાદ રખાવું છું પછી જ્યારે એક્ઝામ્પલ આવશે ત્યારે તમને ખબર પડશે. પણ તમારે આ બધા જ ફોર્મ લર્ન કરવાના છે. આના આધારે આપણે આ લખ્યું અને આના આધારે આપણે આ લખ્યું છે. એટલે આ એ યાદ રાખવાનું અને સાથે સાથે આ પણ યાદ રાખવાનું. નેક્સ્ટ વન, અહીંયા આપણે શું યાદ રાખશું? d by dx of a raised to some function is equal to a raised to some function log a by z d by dx of some function. આ યાદ રાખશું. આ કોના આધારે? આના આધારે. બરાબર? ચલો આપણે આની પ્રૂફ આપીએ. Let's try to prove it. Suppose fx is equal to a raised to x. a raised to x is the exponential function. ઘાતાંકીય વિધેય છે મિત્રો. તો ઘાતાંકીય વિધેય હોય, જુઓ, કે લઘુગુણકીય વિધેય હોય ત્યારે કઈ વ્યાખ્યા વાપરવાની છે? આપણે આ વ્યાખ્યા વાપરવાની છે. તો એ વ્યાખ્યાનો આપણે યુઝ કરીએ. d by dx of fx is equal to limit h tends to 0 f of x plus h minus fx upon h, and therefore or implies d by dx of a raised to x is equal to limit h tends to 0 fx is equal to a raised to x. So f of x plus is equal to a raised to x plus h minus fx a raised to x over h. That is equal to limit h tends to 0 a raised to x into a raised to h minus a raised to x over h. Now h is variable, so a raised to x is constant, so take it outside. Limit h tends to 0 a raised to h minus 1 over h. And we know that what is this limit? Log a base e. So this one. Clear? Fourth one, d by dx of log x is equal to 1 by x. That we know. Once again is a logarithmic function. So suppose f of x is equal to f of x is equal to log x. What is d by dx of fx? This definition, limit h tends to 0 f of x plus h minus fx upon h. This implies d by dx of log x is equal to limit h tends to 0 log x plus h minus log x over h. મિત્રો આની સાથે સાથે આપણે લિમિટનું પણ રિવિઝન જ થશે. Now see, that is equal to, can I write limit h tends to 0 1 by h log x plus h over log x? Yes. Why? mention as a reason? Because we know that log x minus log y is equal to log x by y. Clear? That we know. See, that is equal to, can I write limit h tends to 0 log of 1 plus h by x raised to 1 by h? Yes. So in next page, that is equal to log limit h tends to 0 limit h tends to 0 logarithmic function of 1 plus h by x. What we need? Raised to, we need 1 by h by x. So raised to 1 by x, can I write it? Yes. Now log outside, limit, insert limit inside, limit h tends to 0, 1 plus h by x, here h by x tends to 0, 1 over raised to h by x, raised to 1 by x. So this one is log e, this one is e raised to 1 by x. So that is equal to 1 by x log e base e, that is 1 by x. So what we proved? D by dx of log x is equal to 1 by x. Now, how we are going to remember in other form? D by dx of log some function or d by dx of log mod some function is equal to 1 by some function d by dx of some function. ફરી યાદ દેવડાવશું મિત્રો, આ ખાલી લર્ન કરવાનું છે અત્યારે. આ પણ લર્ન કરીએ, એની સાથે આ પણ લર્ન કરશું. આ પાર્ટ મેં તમને શીખડાયો, આ પાર્ટ આપણે 12th માં લઈશું અને એનો યુઝ આપણે આ રીતે કરીશું. નેક્સ્ટ લઈએ આપણે નેક્સ્ટ સ્ટાન્ડર્ડ ફોર્મ. Fourth one, d by dx of sin x is equal to cos x. Here it is trigonometric functions. So what we have to do? Suppose f of x is equal to sin x. Clear? And now we know that d by dx of fx, શું જાણીએ છીએ આના બરાબર? તો કે લિમિટ, આ વ્યાખ્યા આપણે જાણીએ છીએ ને, f of x plus h minus fx upon h. અહીં જો ત્રિકોણમિતિ વિધેય હોય તો આપણે આ જ ફોર્મનો યુઝ કરવાનો છે ને. તો that is equal to limit h tends to 0. This implies d by dx of sin x is equal to sin x plus h minus sin x over h. You can solve this one with help of first definition also, but it is easy to if we apply second definition. That is equal to limit h tends to 0. What is s minus s? 2cs, 2 cos x plus h by 2y, x plus h plus x, x plus h plus x by 2, that is equal to 2x plus h by 2, that is equal to x plus h by 2, into x plus h minus x by 2, that comes out sin h by 2 over h. Now see, sin h is there, h by 2, sin h by 2, over we need h by 2, yes, take 2 here, give limit to remaining part, here, limit h tends to 0, cos x plus h by 2. Put the limit. Here you get cos x, and this limit is 1. So answer comes out cos x. Yes or no? Yes. Next one, d by dx, d by dx, cos x is equal to minus sin x. So, what we have to suppose f of x is equal to cos x. Dharo ke x is equal to cos x. Now we know that d by dx of fx is equal to limit h tends to 0, f of x plus h minus fx upon h is equal to, this implies d by dx of cos x is equal to limit h tends to 0, cos x plus h minus cos x upon h. Yes or no? Yes. So that is equal to limit h tends to 0. Now cos minus cos, minus 2 sin x plus h by 2. Sum of these two number by 2. Difference of these two number by 2. That comes out h by 2 over h. Once again place here. Here sin h by 2 is there. Over we need h by 2. H is here. Take 2 here. Take 2 here. So limit h by 2 tends to 0. Remaining term minus sign is there. So take it outside. Limit h tends to 0. Remaining term is sin x plus h by 2. Put limit. Sin x and this one is 1. So comes out minus sin x. Now see one thing. We've seen that d by dx of sin x is equal to cos x. And આપણે કેમ યાદ રાખશું? d by dx of sin of some function is equal to cos of some function d by dx of some function. યાદ રાખવાનું છે. આના માટે લખીએ d by dx of cos of some function minus sin of some function d by dx of some function. આ તૈયાર કરવાના છે, લર્ન જ કરવાના છે તમારે. નેક્સ્ટ લેક્ચર નેક્સ્ટ માં જોઈએ આપણે d by dx of tan x is equal to sec square x. Suppose fx is equal to, yes what? Tan x. Now see this definition, d by dx of fx is equal to limit h tends to 0, f of x plus h minus fx over h. This implies d by dx of fx, d by dx of tan x is equal to limit h tends to 0, tan of x plus h minus tan x upon h. Now see, other than sin and cos, whatever may be given, first of all convert into sin cos. Limit h tends to 0 over h. Here sin x plus h over cos x plus h minus sin x over cos x. Clear? Yes. Now take LCM. Limit h tends to 0, sin x plus h into cos x minus cos x plus h into sin x over h into cos x plus h into cos x. Clear? Now see, sin alpha cos beta minus cos alpha sin beta, that is equal to, is a standard form. Limit h tends to 0, h tends to 0, sine x plus h minus x, h into cos x plus h into cos x, sin alpha cos beta minus cos alpha sin beta is the formula of sin alpha minus beta. That is equal to limit h tends to 0, sin x sin h over h into cos x plus h into cos x. Now see, here sin h is there, over h is here, and h tends to 0. Yes. Give limit to remaining term. Limit h tends to 0, 1 over cos x plus h into cos x. Yes or no? Yes. That is equal to h tends to 0. Put 0 here. Cos x into cos x, that is cos square x, and that is 1. And that comes out to sec square x. Yes or no? Yes. So, what we proved? D by dx આપણે શું સાબિત કર્યું ભાઈ? D by dx is equal, tan x is equal to sec square x. But how we are going to remember this standard form? D by dx of tan of some function is equal to sec square some function d by dx of some function. Clear? Next one. D by dx of cot x is equal to minus cos x square. Can I leave for you? Let us try to leave for you. Homework. D by dx of sec x is equal to sec x into tan x. Let us see. Suppose f of x is equal to sec x. Now d by dx of fx is equal to limit h tends to 0, f of x plus h minus fx over h. This implies d by dx of sec x is equal to limit h tends to 0, sec x plus h minus sec x over h. That is equal to limit h tends to 0, 1 over, convert into sin cos, cos x plus h minus 1 over cos x over h. Yes or no? Now see, if I take LCM, then what we get? Cos x minus cos x plus h. But if, can we write this one as a minus of cos x plus h minus cos x? Yes, we can write it. So that is equal to limit h tends to 0. Let us write it. Cos x minus cos x plus h over h into cos x plus h into cos x. Clear? Now take minus sign common because to write greater angle first. Let us take it throughout common. Minus h tends to 0. Minus limit of h tends to 0 cos of x plus h minus cos x upon h into cos x plus h into cos x. So that is equal to minus limit h tends to 0, cos minus cos 2 sin x plus h by 2 into sin h by 2 over h cos x plus h into cos x. Clear? Now see, next page, minus minus plus, limit. See here, sin h by 2. Sin h by 2 is there, over h is there, take 2 there. Limit h by 2 tends to 0, sin h by 2 over h by 2. Remaining term h tends to 0, sin x plus h by 2 over cos x plus h into cos x. See, into this one, sin x plus h by 2 into denominator quantity cos x plus cos h. Now put the limit, that is equal to sin x over cos square x into 1. So can I write 1 over cos x into 1 over sin x, sin x over cos x, and that comes out sec x into tan x. So d by dx of sec x is equal to sec x into tan x. So how we are going to remember? Sec of some function is equal to sec of some function tan of some function d by dx of some function. Clear? In this way we can remember this one. Here also d by dx of cot of some function minus cos x square some function d by dx of some function. Remember this standard form also. Next, let us leave for you d by dx of cosec x is equal to minus cosec x cot x. And how are we going to remember it? D by dx of cos x some function minus cos x some function cot some function d by dx of some function. Now all of you please see here. See, starting from sine. See, let us write it. D by dx of sin x is equal to cos x, whole trigonometric form. D by dx of cos x is equal to minus sin x. D by dx of tan x is equal to sec square x. D by dx of cot x is equal to minus cos x square x. D by dx of sec x is equal to sec x into tan x. D by dx of cosec x is equal to minus cosec x into cot x. Clear? Now see, spelling starting with C, cos, cot, cosec, have a negative derivative. See, spellings starting with C have a negative derivative. Of course, in 12th science we are going to see more 6 standard forms also, inverse trigonometric form. But right now we are not going to discuss it. So these are the standard forms of derivatives. See here, write one note. D by dx of fx is equal to limit t tends to x, f of t minus fx upon t minus x. Clear? This one is the derivative with respect to x at x. Now, if we wish to find d by dx of fx at particular point x is equal to a, then what? Then limit t tends to x, f of t minus f of a over t minus a. Clear? Next, this one is according to first definition. Now second definition, d by dx of fx is equal to limit t tends to x, f of t minus f of x over t minus x. And suppose we wish to find derivative of function fx at given point x is equal to a, then this comes out, sorry. Second form, which one? Limit h tends to 0, f of x plus h minus fx upon h. So second form is limit h tends to 0, f of a plus h minus fa over h. That means whenever we want derivative at a particular point, then this one. In this example, that means this is standard form. If we take x is equal to a, then this is the derivative of a function at a given point. Let us take very simple example. For example, find d by dx of x square at x is equal to 1. Vyakhya madati, using definition. See, f of x is equal to x square. This is not a trigonometric form. So which function, which definition we have to apply? First one. Limit, d by dx of fx is equal to limit t tends to x f of t minus fx upon t minus x. This implies d by dx of x square is equal to limit t tends to x t square minus x square over t minus x. But what we want? We want d by dx of x square at x is equal to 1. So take x is equal to 1 here. So limit t tends to 1, t square minus 2 square over t minus 2. And we know that that is of the variable form. Variable raised to n minus constant raised to n times constant raised to n minus 1, that is 2. So with help of definition, we can find derivative in general also, and we can find derivative at a given particular point also. Clear? In next lecture, we are going to see more examples or more results